In this video, we're going to look at the cost of moving. So Jay is moving from an apartment in Miami to one in Orlando. If Jay moves on a weekday, he will need more movers time to pack, load, unload, and unpack because his friends will not be able to help him. If he moves on a weekend, he can get his friends to help, cutting down on the number of hours he will need to hire movers. Move Out is a company that supplies movers, trucks, and moving equipment. They have given them the following estimates. So there are two sets of estimates. There is a weekday move estimate and a weekend move estimate. And you will notice there's a difference. On the weekday, it's going to take 6 hours for them to load and unload because there's no help. On the weekend, when Jay's friends help, there are less hours of loading and unloading, and the same holds true for packing and unpacking. So therefore the cost is going to be $720 without friends, $400 with friends. So there's quite a bit of difference, $320. So Move Out charges a set hourly moving team rate for loading and unloading and a different set hourly moving team rate for packing and unpacking. So if we want to determine the hourly rates, the first thing we're going to do is we're going to let X equal the cost of loading and unloading per hour and Y equal the cost of packing and unpacking per hour. So what we're creating here is a system of equations. And remember, when we're talking systems of equations, that's when you're using AX plus BY equals C, and then you're going to do another AX BY equals C. So there'll be two equations that we're going to use. So the first thing we want to do is we want to write the equations. So remember, loading and unloading is going to be X. So this 6 would be 6x, and on the weekend move, this would be 4x. When we look at packing and unpacking, we're using y, so this would be 5y, and the other one would be 2y. And then we're going to write those in equation form. So this 720, that is going to be our C amounts, and the 400. So our equations would be 6x plus 5y equals 720. The second equation is going to be 4x plus 2y equals 400. So I brought those equations forward, and one way that we can solve for this is we can solve by graphing. So we would take our two equations and put them in slope-intercept formula. So remember, slope-intercept is going to be y equals mx plus b. And this will allow us to easily graph the equation. So the 6x plus 5y equals 720. When we move everything over, we get y equals negative 6/5 x plus 144. For the second equation, when we move everything over, we would end up with y equals negative 2x plus 200. And just to show you step by step, just in case you need it, which you shouldn't, but I will show it just in case. So 4x plus 2y equals 400. We want to subtract the 4x first, and we end up with 2y equals negative 4x plus 400. And then we want to divide everything by 2, and we wind up with the equation y equals negative 2x plus 200. And that is how we got from standard form into slope-intercept form. And then you would simply graph it, and just a rough graph would look something like this. And to find out what our rates are, we would look at where they have the point of intercept. And the point of intercept on here ends up being 70, 60. Now remember, The x and the y are going to be the rates for each of the things. So to interpret this, this implies that it's $70 per hour for loading and unloading, because remember that was our X amount, and it will be $60 per hour for packing and unpacking, because that was our Y amount. So in this second example, we're going to look at another way to solve a system of equations. It's going to be the same type thing. So Samantha is moving from Madison, Wisconsin to La Crosse, Wisconsin. She will do all of the packing and unpacking by herself with her brother. The moving company quoted a price of $1,250 for 8 hours of loading and unloading and driving 130 miles. The company quoted the same price if the truck drives an extra 30 miles to pick up Samantha's brother. Samantha figures that with her brother's help, she only needs to hire movers for 6 hours. How much does the company charge? Hire the movers. So how much does the company charge per hour for the loading and unloading? How much do they charge per mile for driving? Okay, so like before, we're going to assign our X and our Y. Our X is our cost of loading and unloading. Our Y is our cost of packing and unpacking. So to load and unload, it's 8 hours without the brother and 130 miles. With the brother, it's only 6 hours, and because we have to add in the extra 30 to pick up the brother, it becomes 160, because they said 130 plus the 30, and that is to pick up brother. Okay, so the cost would be $1,250 either way. So that would remain the same for both of them. So we need to write our equations. Remember, the load and unload is our X's, and our mileage mileage is the Y's. So this should be mileage. Okay. So our two equations are 8x plus 130y equals 1,250. And the other equation is 6x plus 160y equals 1,250. Okay, so this time we're going to use the elimination method. So we're going to take our two equations and stack them. And when we use the elimination method, remember, we want either the x values to be the same or we want the y values to be the same. Well, in this case, I figured it's easier to make the x's the same. So I know 8 and 6 both go into 24. So I'm going to multiply the top equation, everything in it, by -3. So that way when we add it together, it's going to cancel out. And on the bottom equation, I'm going to multiply it times 4 to get 24. So we end up with -24x minus 390y equals -3,750. And then 24x plus 640y equals 5,000. So the -24's cancel out. We end up with 250y equals 1250. Divide, and we get y equals 5. So now we need to solve for our x value. So we're going to take our 5 and plug it in for y in one of our original equations. So I just chose the first one, plugged 5 in for y, and then solve for x, and we ended up with 75. So the cost ended up being $75 per hour for loading and unloading, and $5 per mile for the truck rental.